Hi, I'm James McGuire, and on today's eSpeaks, we're talking about a really interesting topic. We're taking a look at AI infrastructure, what it is, what it means to build one, and how companies can optimize their AI infrastructure. To discuss that, I'm joined by Stoica, professor at UC Berkeley, executive chairman at Anyscale, and executive chairman at Databricks. Very good to have you with us today.
Thank you. Thank you. Very glad to be here, and very much looking forward to our conversation.
Great. Well, I'm amazed, even before I ask you a question, I'm amazed at the number of titles you have. Obviously, for some people, being a professor at UC Berkeley would be a full-time job. You're also executive chairman at Anyscale and at Databricks. Tell me, I mean, how do you keep up with it all?
Yeah, this is also historical, obviously, you know, spending a lot of hours per day. But everything started at Berkeley, and at Berkeley, I was co-director of several labs, and these labs developed some of this technology, which is a foundational for both Databricks and Anyscale. In particular, we developed at AMP lab. We developed AMP. It stands for Algorithm, Machine, and People. We developed Spark, which today is de facto standard for parallel data processing.
Right.
And this is the open source around which Databricks was founded. I was one of the co-founder, and I was the first CEO of Databricks, and then I moved to the role of executive chairman. And then later, we started the work on Ray, which is the open source for scaling machine learning workloads. And this was developed again at Berkeley as part of the next lab after AMP lab, which was RISE. RISE stands for Real-Time Intelligent, Secure, and Explainable Systems. And this is so the RISE system was a foundation of starting Anyscale, and I've been also executive chairman at Anyscale. So that's kind of you know, how things happened and why I have all these titles.
Well, I don't think you're someone who has a lot of free time, so I respect that. That's great. So I think there's a lot of companies out there that are getting on board with artificial intelligence or are already on board, but they're confused. They're not sure what to do. So let's see if we can give them some advice. When companies seek to build an AI infrastructure, what exactly is that? What are the elements in effective AI infrastructure? I know they're going to need probably a compute platform, a large language model. They're going to need personnel. What do they need in your view?
Yeah, so the ultimate goal of building a machine learning platform is, of course, is to use machine learning to get value out of their data to improve their businesses, their products, their services. So to build a model, obviously, first you need, at least traditionally, you need data. And many companies leverage their data, which they see a lot of value on it because it's data gathered from their operations, maybe their customers and things like that. And starting from the data, first they need to pre-process the data. And then once they pre-process the data, typically they train the data. They train a model based on the data. Once they train the model, actually the model, it has some parameters. They are called hyperparameters, like, you know, maybe the number of layers or things like that. So people do tune that model and basically try different parameters of the model, training on the same data to see which model performs best. Once they arrive at a model which they are happy with in terms of performance, then they deploy it in production, the model to serve the model. It can be recommendation systems or something like that. So that's kind of what happens. Now, on top of that, there is an entire life cycle because the companies accumulate more data, so they want to take advantage of this newer data, and they want to retrain the model and then deploy it again in production. And this is, you know, it's not easy because these models are a little bit like black boxes. So it's not necessary that you add more data, the model will become better. It's also that sometimes a model you train on some data, but the distribution of the new data you get from the new users, for instance, you have a new offering or things like that, for which models are not really trained, the model can, performance can degrade, right? As the new data arrives, the data which was not, the model was not trained on. So this is what traditionally so the components of the machine learning infrastructure is data processing, training, tuning that model to find the best version of the model, and then deploying it in production. Now, with large language models, things are a little bit slightly different. For large language models, you have also the ability, in some sense, to program them. You may have heard about this prompt engineering. So when you ask and you create a question for a large language model, you can also provide instruction to that large language model. So you have a lot of flexibility with a model which is already trained to change its behavior. In some sense, you can think about like a database, right? In a database, you send a query and you get an answer, and the query can be pretty sophisticated. It's a SQL program.
Sure.
Now, instead of a SQL program, you have a program which you write in English, right? So that's kind of one way to think about. So for large language models, then what people do, and also because they are large, they don't do as much training from scratch the model. What they do either they do this prompt engineering by asking sophisticated question in which add their own data to get the answer they need, or they use their data to fine-tune it. Fine-tuning is from the base model, then they add their own data to make it better for that the particular domain of the company, right? It's like, for instance, for the particular application, like, for instance, if you provide customer service, then you are going to feed that that model. You need to fine-tune that model with customer service logs from interacting with your customers, and then that model is going to become quite a bit better in providing answers to the new questions coming from your customers.
I think it's really interesting that some of the models you refer to as a black box, you can feed them more data, but they're actually not going to give you a better result. How can you avoid working with one of those black box models? I'm certainly not all the models are black boxes, correct?
Yes. The most deep learning models are black boxes, in the sense like almost humans are black boxes, right? They cannot explain necessarily everything we cannot explain everything we are doing.
By the way, did you just compare them to human? They're inscrutable as humans. I like the analogy, if I'm understood it correctly.
It is.
So the human soul and the deep learning model are also they're both pretty complex things.
Yes, I wouldn't say soul. I think they are more. It's more of the mechanism, not necessarily the soul and the awareness.
Yeah.
But there are some similarities. As you know, the architecture is still based on some kind of neurons, right? So these are a more black box, and that's why, one thing I didn't mention for these models, that's why you need, it's like data scientists, you need machine learning engineers, you need experts to train these models and to deploy this model, to curate the data for this model and things like that. It's because if the data is bad, the model will be bad. There is no question about that.
Right.
Now, before that is classic machine learning. Classic machine learning, this was, where you have random forest or things like that, which it's more, you have statistical models, and these are more explainable, more understandable. They are more, they are not as black box. You kind of understand. These are the input. This is the model is going to. The results the model is going to give you. But now, when you are talking about deep learning, when you are talking about large language models, which is just another deep learning model, you know, the explainability is a challenge, and that's why you see all the discussions and about these models, about how to regulate them and things like that.
Well, all right. What about the role of distributed computing and unlocking AI's potential? How does that work for companies?
So it's very simple. So here, if you look at the trends, um, it's like these machine learning workloads, their demands growing much faster than the capabilities of a single node or a single processor.
Right.
And the scaling is very important because at least so far, and it seems also for the foreseeable future, despite, you know, there are some articles you know, taking an opposite position, the scaling law for this model still holds. By scaling law means that the larger the model, the better it's going to perform.
Right. Okay.
Right? It's like there are now probably, you know, like it's not, you know, like hundreds of billions, trillions of parameters in these models. So you have now again, it's like these demands growing faster than capabilities of a single node or a single processor, even when you are talking about this GPU, a specialized hardware. So
Right.
therefore, there is no other way to run these models, to train these models than using distributed systems, right? Running the models on more than one GPUs, on more than one node. And this is fundamental. And it's fundamental, it's not only because these models have a huge requirement in terms of computation, but they are large, so they have a huge requirement in terms of memory. And while for computation, you know, you can improve the number of flops, you know, floating point operations, by being smarter, changing architectures, you know, architecture innovation in the silicon. It's much harder to grow the memory because the memory is, you still need, you know, for each bit of information, you still need one, you know, at least one transistor. So that's, and the Moore's law and then our scaling, you know, as we all know, they slow down considerably, even, you know, it's so then it comes at an unfortunate moment for us because on the other hand, the capabilities of the hardware doesn't grow as fast as it used to be, at least in particular the memory capacity, while the demands of this new workload is skyrocketing. Right. So that's why you see, like, you know, it's like they train these very large models. They train on thousands, tens of thousands of GPUs. That's why you see these new startups which are building these models, like Anthropic, raising 1 billion or so of dollars, and all these companies raise 100 million in Series A, right, which was unheard. Most of this money goes in spending on resources, GPUs, to buy GPUs to train and serve their models, and a lot of, you know, this training and the serving of these models, the inference of this model happens on distributed systems.
Well, can I clarify the idea of distributed computing? Is it distributed typically within, you know, one large data center? Is it geographically distributed? How distributed is it in a physical sense?
Yeah, typically it's within one data centers, but we are seeing it's depending also on the workload. Like, for instance, I mentioned to you early on that some of the workloads is like, for instance, when you tune a model, you try the model with different parameters, you train it with different parameters. So each of these instances, it can actually run on different data centers and even in different clouds. And this is a trend. Actually, the newest lab at Berkeley, which, you know, I'm involved, I'm leading, it's sky computing. And this is about how to make it much easier to run these workloads on multiple data centers in multiple regions in the same cloud or across clouds.
You're using the term sky computing. Am I hearing that correctly?
Yeah, sky
So
computing.
it's really it's a version of cloud computing, but it's really a way of saying sky computing is distributed computing.
Is distributed computing at where it's not this typically so far distributed computing. It's on one cluster in one data center, like you mentioned. The sky is taking that to the next level, like you very well asked earlier on, whether, you know, are these systems are these models trained on different across data center or things like that.
Right. Right. Okay. Interesting.
So
Yeah.
so far this hasn't happened much, but because of their growing requirements, that's the next logical step, and you can
Interesting.
already see the first signs.
All right, I'm gonna Google the term sky computing. That's a new one on me, but it sounds pretty cool. Let's drill down to the Anyscale offering. You're executive chairman of Anyscale.
Yeah,
So what does the Anyscale company do, and how does it serve the AI needs of its clients?
yeah. So Anyscale, it's was started. You know, it's built around, it's commercializing the Ray open source project. The Ray open source project was started at the end of 2015, 2016. And the main goal is to scale these emerging deep learning applications.
Mhm.
Okay, we started with deep learning and then reinforcement learning, which is another branch of machine learning, which
Right.
is very, it started to be more and more popular. It's actually, it's used to today to fine tune the most successful large language models. If you heard about this reinforcement learning with human feedback, you know, that concept. And from day one, we build it to, uh, to scale these workloads, right? So that's what the goal. The goal is to scale machine learning workloads. And the reason it's so hard is because if you run it on one machine, it's easy. You have your machine, everything is there. But obviously, when you start to scale and you have multiple machines, you need to start to manage these machines. You need to deal with what happens when a machine fails, what happens when the network, you know, it's slow. So all of this becomes so much more complicated. So that's kind of, and because it was very hard for machine learning experts to run, you know, to run their workloads in more distributed fashion, our goal was to, you know, it's quite, you know, with a team of people, few students, including Grover Nishihara, who is now the CEO of Anyscale, and Philip Morris, who is the CTO of Anyscale, to build these tools to make it much easier for people to develop new models at scale, train them, and serve them. Our holy grail was, in some sense, and of course, we still need to get there, but we are closer, hopefully, closer, hopefully closer than we started, is to
Right.
make it, you know, building this you know, machine learning applications almost as easy as if you were to build using your own laptop, on your own laptop.
Uh-huh. Okay.
So that's kind of the goal, right? Because these are experts. They don't want, no machine learning expert wants to deal with distributed systems, to manage nodes, to find the nodes, to,
Right. Right.
you know, take care of the failures and restarts all these
Right.
jobs when it fails. You know, it's very complicated. So you
No,
want to abstract away all this complexity from the developers.
I definitely see the demand for that. There's a market for that, no doubt about it. I'd like to get your glimpse if you look into the future. I mean, if you look at, say, the next 2, 3, 5 years in AI infrastructure and distributed computing, what sort of things do you see going on? What can we get ready for now?
Yeah, I think that distributed computing as a foundation for these machine learning workloads is here to stay. I think that also what you are going to see is that I mentioned to you that these machine learning platforms, you need to, so they need to support a bunch of workloads, training, serving, like I mentioned,
Mm-hmm.
fine-tuning or model tuning,
Yeah.
or data preprocessing. And I think you are going to see more and more that people would like to unify the support for all these workloads, because it's much easier to run all these workloads on a single system than on different systems. And so far, many of these machine learning platforms, which have been developed they are using different systems to scale different of these workloads. So you do training, you use one system. You do serving, use another system to scale. You use and so forth. And now and that's difficult because you need to manage this different distributed system and then stick them together, right? Which is hard, right? It's hard to develop, hard because they have different APIs, hard to manage them, hard to deploy in production. It's also slow because you need to move the data, and there's a lot of data between them. So you are like to see, and that's where also Ray comes in because it's a unified platform to support all these workloads. So you need only one platform. So I think you are going to see a lot of more push either on the open source or commercial offerings, which provides you an end-to-end platform for this machine learning, to support these machine learning workloads. So that's one thing I was going to see. I think the second thing you are going to see is, and it's already happening with these large language models, you are going to see a lot of, so to speak, more, the people who are going to take advantage, the developers who are going to take advantage of these technologies is going to grow. It used to be that you need a data scientist, you need machine learning experts in order to build this application, to develop these models, see whether they are good, whether, the distribution, like I mentioned, of the data changes, is the model still behaves like you intended to. But with these large language models, it's much easier, and that's because again it's like you think about ideally you use English to program them, right, in the English language. You are going to see, and you're already seeing existing developers of the existing applications taking advantage of those to add feature to their application, like these copilots, right? Provide me suggestions if I'm I'm writing the code, provide me suggestions about how this function should be written, or tell me what I've done wrong. So now it's going to they are much more the barrier to use the technology is going to go lower and lower, so everyone can use them. And I think this is huge for democratization of these technologies.
No, I think that the democratization of AI, that is a huge mega theme. Really interesting that you spotlighted that, because I think that is it's not just the technology itself is developing, but the use of it is spreading because it is being democratized. I think I totally agree that's a mega trend.
Because it's also this kind of, it's more natural language, how you interact, and everyone needs, once you need, how to speak and so forth, you almost can use them to your advantage, right? I think the other thing what will happen is, like you alluded to, you are going to see these workloads happening not only in one data center, but across data center, even across clouds. It's just because the scarcity of the resources, and this is what is happening today. Now today, many companies have difficulties to find GPUs. It's not about how much they cost, it's about their availability. Right. And that's why it's very important to provide the flexibility of where they can run their workload, and to make it easy, because then they can look for GPUs not only where they have the data in their region, say in AWS, but in other regions across the globe in AWS, or they go or Google Cloud, or Azure, or Oracle. And you see that the signs of emerging of this kind of new GPU-only clouds, basically, or they are focused on the GPUs, like CoreWave, like Lambda Labs, and so forth. And I think the final one, the trends, it will be, and you see that, is like, I like to point out, there will be a lot of work and it's a lot, there is very challenging about how to regulate these models, about the copyright laws, about how you are going to apply them, right? And that's kind of is going to go on, and we'll see how things are going to fall into place. But it's a difficult problem. But again, one thing you can think about, if they are you know, this large language model, for instance, are behaving a little bit like, you know, maybe like humans, at least behavioral, not, you know, their
Right.
feelings. They don't have feelings.
Sure.
You know, you can use some inspiration about the way we regulate our own society.
Ian, I think you said it. It's a lot. It's a lot going on. It's going to be a fascinating sector to follow in the years ahead. Thank you so much for sharing your insight today, and I hope you come back and talk with us again sometime. Thank you.
Thank you so much. Has been a pleasure. Bye-bye.